Hello, my friends. Thank you very much for subscribing to our channel. ABC are three integers. Then how to prove that the value of the following complex expression is divisible by 3? Why not give a try, and we will come back soon. This question is somehow friendly, as there are several very similar factors in those three terms. And in the different factors there are just a few more terms with square. So it clearly implies that we should refer to the formula for the difference of square. After applying this formula, we can see that all the three terms have exactly the same factors. So we can easily complete the factorization. And we get 5 factors. The factor 2 is obviously not divisible by 3. Then in order to prove that the original expression is divisible by 3, we have to prove at least one of the other 4 factors is divisible by 3. How to prove it? When we don't have a better idea, at least we can use the most straightforward one. Let's first look at the remainders of ABC divided by 3. There are only 3 possibilities, namely, 0, 1, and 2. Combine them together, in fact, there are only 27 cases in total. Then we just need to prove that in each case, at least one of the 4 factors can be found that is divisible by 3. In fact, in some cases, there is more than one factor that fulfills the requirement. And due to the existence of some symmetries, it is not necessary to always search the target case by case. Anyways, this method is very simple in terms of idea, but in terms of operations, it is a little bit complicated. The other method is the other way around. In terms of idea, we need to think about it a little more, but from the perspective of operations, it is much simpler. Specifically, this time we only care about these 4 factors. If either of A minus B and B minus C is divisible by 3, the requirement is fulfilled. So we only need to consider the cases where neither of them is divisible by 3. So now, we only need to consider 4 cases in total. That is, they have the same remainder when divided by 3, which are either both 1 or both 2. Or they are different. Namely, one is 1, and the other is 2. If their remainders are the same, we will first calculate their difference, and then calculate the remainder of this difference divided by 3, which is equal to first finding the difference of the remainders divided by 3, and then finding the remainder of it divided by 3 again. Since the difference between the remainders is 0, the final result is 0. So what is A minus B minus C equal to? It is equal to A minus twice B plus C. It is divisible by 3. In addition, we also know that 3 times of any integer must be divisible by 3, for example, 3 times of B is divisible by 3. We add them up and get exactly A plus B plus C, which must be divisible by 3. In the other cases, where the remainders of A minus B and B minus C divided by 3 are 1 and 2 respectively, this time we first add them up and calculate the remainder of the summation divided by 3. It is equal to the remainder of the summation of the 2 remainders divided by 3. The summation of the 2 remainders is equal to 3, so the final result is also 0. What is A minus B plus B minus C equal to? It is equal to A minus C. A minus C is divisible by 3. Then C minus A must be divisible by 3 as well. So, we are done. In any case, this question is somehow friendly. Why? Because the very first expression already strongly implies that we should factorize it. Then what about the following 2 expressions? How can we prove that they are also divisible by 3? The key point is still the factorization. In fact, their results are almost the same as the one we just analyzed, with only a small piece of difference, which is the factor 2. But they really seem more difficult, don't they? Thank you for watching, and see you next time.